All right, and welcome back. In this video, we are going to be going through Chapter 5, Section 2, which is ways to prove that quadrilaterals are parallelograms. By the end of this video, we should be able to prove that certain quadrilaterals are indeed parallelograms. Let's have out our guide and notes. Let's begin. So the definition of a parallelogram gives one way of proving that a quadrilateral is a parallelogram. Show that both pairs of opposite sides are parallel. The following theorems provide 4 more ways. So if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if we have a diagram that looks something like this, where opposite sides are congruent, then we're going to have a parallelogram. If one pair of opposite sides of a quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. So if we know that these sides are congruent and they're parallel, then we're going to have a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So again, if we have angles that are congruent. And lastly, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if we know that we have our diagonals, they bisect each other, then we know that we have a parallelogram. In example number 1, we have to decide each quadrilateral if it's a parallelogram. If the answer is yes, then we're going to state the definition or theorem that applies. So we have letter A. We have what looks to be a quadrilateral A, B, C, D. Looking at it, let's go through our 5 ways to prove quadrilaterals are parallelograms. Do we have any opposite sides that are congruent? No, we do not. Which means we don't have any opposite sides congruent and parallel. So there's 2. We don't necessarily have any congruent angles, which is 3. We do not have 2 diagonals cutting through that are bisecting each other, so we can't prove it that way. But something that I notice here is that we have what looks to be alternate interior angles. AC can be a transversal, which means that AD would be parallel to BC. And we have these 2 arcs here, which means that we have alternate interior angles again, which means that these 2 segments, AB and DC, are parallel. So we can say our solution is yes, it must be a parallelogram because both pairs of opposite sides are parallel. Again, since we have those alternate interior angles. Awesome. Let's look at B. We have quadrilateral PQRS. Let's look to see on what we have for PQRS. Well, we have PQ is congruent to SR. We have the diagonal QS is getting bisected. We don't necessarily know too much about diagonal PR, but we do know that PQ and SR are going to be congruent. And since only one diagonal is bisected, we can't say that this is a parallelogram. We don't know that this is congruent to this. We don't know that. Unfortunately, we don't know that, so we can't say those diagonals are getting bisected. And again, we only know PQ is congruent to SR. We don't know anything about PS and QR. So this is not going to work. A worked, but B. All right, with this, please work on problems 1 through 10 on the guided notes and resume when you're ready to move forward. In example number 2, we're asked what values of x and y have to make the quadrilateral a parallelogram. Well, looking at this, we are going to be using the idea that we have these diagonals getting bisected, which means that we're going to have 5y plus 3 should be congruent to 3y plus 15. Likewise, 3x should be congruent to 2x plus 5. When we solve, we get that x is going to be equal to 5 and that y is going to be equal to 6. Great job. Please work on problems 11 through 15 on the guided notes. Keep making yourself proud. Keep up the good work. Let us know if you have any questions, and we'll talk to you soon.